Okay, so hi, how's everyone doing tonight? My name is Michael. I'm going to be talking a little bit about Git. More importantly, I'm going to be talking about some Git internals and how Git works on the inside. So a lot of what I'm going to be talking about today is not your introductory Git talk. It's your I've used Git before and I kind of want to know a little bit more about it. So quick show of hands. Anyone here completely new to Git? Who's never used it before? Okay, one honest hand, two honest hands, three honest hands. Okay, that's not bad. So this talk isn't going to be overly friendly to you, I could say, but there's still a lot of cool stuff you can get out of this. Git's a version control system. It's really awesome. I suggest you go out and learn it. But so there's your little disclaimer. As I said, my name is Michael Timbrook. I'm a second-year software engineering student here at RIT. There's my alias. You can find me on Twitter and GitHub with that, and SlideShare, I think. I want to thank you guys all for coming, actually. So, without further ado, what is Git? So, Git, according to its man page, is the stupid content tracker. You guys can thank Linus Torvalds for that one. He's a wonderful man. But what is Git really? Git is a distributed version control system that you use to version your code. But it's a little bit more than that. It's also, actually I want to read one more thing on here. If you look at the full description, we have Git is a fast, scalable, distributed revision control system with an unusually rich command set that provides both high-level operations and full access to internals. So Git is more than just a versioning system. It is also a full tool set for building a workflow. So those are the main points I want to point out of what Git really is. So I like to separate all the commands because there's 170 some Git commands. A lot of them you don't see a lot of the time. Most of the ones you guys are familiar with are these versioning commands, which are like add, commit, reset, push and pull, the ones that you use every day just to version your code. Then we also have these workflow commands, like merge and rebase, and also like branch. I'd also put push and pull in there. These are more, your branching model you're going to have for your workflow and how you're going to handle your Git talk, not your Git talk, your presentation. Why am I stuck on presentation? Anyway, one more thing I want to say. I want this talk to be interactive. So you guys are all kind of sitting out here staring at me right now. It's wonderful. If you guys have questions, please ask them whenever. Most of my talk is going to be done from the command line, and I'm going to be doing demos. So if you missed something or you didn't catch anything, raise your hand, ask me, or just shout it out. So what I want to show you guys real quick is actually making a Git repository. So unfortunately, I'm going to be craning my neck back here to actually look at the screen because I don't have it mirrored. So what is the correct way to make a Git repository? The correct and respectful way to make a Git repository. So for you that are new to Git, this is your 3 minutes of Git crash course you're going to get. So Git init SSC. And there we are. We're in a Git repository. And Git status is happy. Everything's wonderful. So if we actually look inside here to our .git folder, you can see there's a lot of stuff in here. What we're really going to be focusing on is that objects and refs directory down at the bottom. But actually, I want to show you guys something first. So we're going to make a file here. We're going to call it, and then let's go, F. Here it is. We'll call it booker.txt. And we'll put in here, character is,
It's not spelled right.
There's a C.
Yeah, there's a C in there.
C-H-A-R. There you go.
None of those
Hard
words
to
look
see
wrong
like
to
this.
me, 'cause I can't spell.
So we're going to make a file, we're going to add it to our staging area, and we're going to commit it with message, a quality file. And there it is. That is the respectable way to creating a Git repository and adding a file to it. And if you look in the .git folder, you'll see we have some more stuff in here. We have our objects directory has some files in it now. And you'll notice the refs head master down here. You can see now we have a master branch that we're on. So I'm actually going to go back. Come on. Computer's being weird. There we go. So what is this? We have some stuff in here. It's kind of dark. You can't really see that. Wow. So we have these objects in here, and what Git really is at its core is what a Git repository is anyway is a collection of objects and a system of naming those objects. The system of naming those objects we call refs, and those objects, as you can see, are these objects. They're stored inside the objects directory and actually inside a subfolder, which is the first 2 characters of the hash. And then the remaining 38 characters of the hash are actually the file name. The reason why Git does this is because file systems don't like a lot of loose files everywhere. So by breaking them down, you subdivide the problem by 256 by taking the first 2 characters out. So, yeah, and then refs. So we see we have refs here, and if you ever looked at what it means to be a Git branch, you'll see that this file has to exist. So this is the master branch. Git internally refers to branches as heads, and heads exist in the ref namespace. So you can actually do this cool thing with your branches and actually namespace your branches beyond that. That's where that slash kind of comes from. So if you have feature branches and you go feature slash something, they'll actually show up in an additional namespace or subdirectory. And there's some other cool stuff you can do with merge with that, but I'm not going to be getting into that. But you can actually, there's this thing called ref spec, which is where everything is spec'd out for how this is defined and what these file names look like and everything. That's a whole other thing as it is. I'm not going to be getting into that at all, because that's not what we're here to talk about. So we know what it means to be a Git repository. You need to have objects, and you need to name these objects. So what we're going to do is we're going to actually make a Git repository without using any of the conventional Git commands. Actually, we're going to make a Git repository without using any Git commands. So this is going to be fun. So we're going to mute this. Oops. There we go. We're going to get rid of this directory, and we're going to make directory and call it SSE. So Git status doesn't think this is a Git repository. So it's not enough just to be a folder to be a Git repository. What else does Git need to be a Git repo? Yes.
.git folder.
It does need a .git folder, so let's make that right now. Okay, so we got a .git folder. Git status still isn't happy. So it's not just enough to have a .git folder to be a Git repository. What else was it that you needed to be in a Git repository? So we had, yes?
You have to initialize it?
So we're not going to be using Git commands just yet.
Right.
We are making a Git repository completely from scratch. So what does it take to be a Git repository?
Need a head file?
We will get to that, yes.
Git ignore?
You don't need to Git ignore. That's just some extra stuff that you can do with Git. There's actually, yes?
Objects.
We do need objects. So that's the first thing we're going to make. We're going to make that objects directory. I did that. So, okay, so we have our objects directory. Git status still isn't too happy with us. We're also going to need refs. So we need to have some place to name our objects. So if we do this again. And then another thing we're going to need our heads. So we need to have our branches. So we're still not a Git repository yet. And you'd already said we need our head. So that's the one thing we're missing for Git to be happy to be a Git repository, is we need a head. So this is where a little bit of that ref spec syntax comes into. What we need to do is we need to point our head to one of our refs. So you just do that by making a ref and pointing it to, we'll point it to our master branch, even though this doesn't exist yet, but we're going to tell Git that our head is on our master branch. And there it is. You can see I have OMyZSH on here, so you can tell if I'm in a Git repository or not. But Git is happy, so that's all it takes to really be a Git repository. And it really isn't much.
Don't you need a master file in your heads folder?
No, right now we've done absolutely nothing. That master file isn't going to point to anything, it's not going to point to a commit or anything. All it takes to be a Git repository is to have objects and refs. And then obviously your head, so you know kind of where you're going to be starting off from. You actually, in 2 versions ago of Git, you didn't need to have the head.
Oh.
That's something that in 8.2 that came out. But so that's all it takes to be a Git repository, is you need to have these objects and these refs. So my notes here. So Git's happy with that. So as I said, there's 170 some Git commands, and on an average basis, you probably interact with not even 20% of them. The most common things you do in Git is you add a file and you commit a file, and you push or pull. Like, on a day-to-day basis, you really don't do much more than that, unless you're merging things together or you're having problems with your repository. So I'm going to show you guys some commands that Git has that you've probably never heard of before, and probably are never going to use outside the scope of this talk. So there's this command called hash object. So hash object, what it does is it computes the object ID and optionally creates a blob from a file. So as you know, Git bases everything around hashes. Your commits have hashes. You guys are probably familiar with seeing that as a commit hash. But that's only one type of object that Git has. Git also has these blob objects. So blobs, basically, they store content. They don't even store file name or directory or location or anything. They're strictly just content. So every time you add a file to your staging area, this is the first step that it goes through. It takes everything in your directory, hashes all your files, and hashes files individually, and takes that hash, compares it to see if you already have a blob that exists with it in there. If that blob already exists, then you don't need to make a new blob because it's going to have the same hash anyway. But if you rehash the file and it's something different and that hash doesn't exist in your Git repository, you have something new and something's changed. So hash object will go, you pass content into this. Git add uses hash object when checking files. But so you take a hash of an object, you add that object to the objects directory. And the type of object we're going to make is called a blob. So we're going to have this. Yes. So we can do this a few different ways. I think I'm going to use echo, because I'm not going to make a file yet. I'm literally going to create a blob with some content. So, and I'm not going to use a text editor either. I'm going to literally give hash object some data, and it's going to put that data in the object store for us. And one more thing I want to do over here. It's going to be a fun one. Yeah, there we go. That worked. So here's the inside of our .git folder. That'll continuously update as we do some things. So I'm going to echo some stuff into here. There we go. Gotta pick my inspirational quotes for my talk. I honestly just Googled some random quotes. So we're going to take this, and we're going to pipe this into Git hash object. We're going to tell it to write this to our objects directory, and then we're taking our input from standard in. You can optionally define a type. The default type of hash object is a blob, which again, as I said, is just data. And so you could do that by saying blob, but we don't need to do that. So if we do this, you'll see it returns to us a hash, and inside our objects directory, we now have an object. So I'm actually going to copy this here, and I'm going to show you another command called Git Cat File. This one's actually kind of cool. I got this thing here. We use cat file is going to read an object from the objects directory with a hash, and it's going to spit out us some information about it. So if we cat file and we ask for tact, which is type, we can see that that file is a blob. And we can optionally, we can ask for its size, which isn't really useful at all. We can also have it print out the content of that. And you can see that object stores our data. And that's all the metadata that is stored in these objects. A type, a size, and the content and data itself. There's nothing else in there. That's all we have. And you can also see Git status doesn't think anything's happened yet. Really nothing's happened yet. We just wrote an object to our objects directory. We have nothing pointing at it. We don't know it exists. It's just there. So that's a blob. So what does git add do next? Git add adds things to your staging area. And your staging area is what you build up before you wrap a commit around it and commit your changes. So what we need to do next is actually make a tree. So what tree objects are, they're another object type. So now we have blobs, now we have trees. What trees basically are directories. They store file information, so file name, file type, read-write information, and they point to a blob. And they have blobs in them. And then trees can also point to trees for subdirectories. So we're going to use another obscure Git command called write tree. Yeah, I'm going to do write tree. This is really hard looking back like this. Okay. Actually, no. I'm not going to write a tree yet. I'm actually going to, writing the tree comes after you put it in your index. Excuse me, I'm wrong. I'm jumping ahead here. So we're gonna update our index. You can't see it now, but just like head, there'll be another file in here called index that actually stores all the information about the current changes in your staging area. And then when we use write tree, we gather all that information from index and we actually make a tree out of it. So if we update index, we're going to add a file from cache info, saying to cache it and put it in the staging area. And we're going to give it a file node, is what it asks for next. And this is just read write. You don't need to memorize that, it's not important. And then we give it a hash. So I'm going to paste the hash in there from before. And we're going to add to our index this file. And it didn't like
I think
that.
that was the wrong hash.
That's the only hash I had.
C498 versus.
See the object
Oh,
directory,
right.
the
it
first
starts with
two.
the first two.
Yes.
Never mind.
So, right. I completely forgot something. We need to give it a file name. Git doesn't know what the name of this file is, and you can't have an empty file, or like an empty string named file. So that doesn't work. So we need to give this a name. Give it this right here. So there it goes. So as you can see, we now have our index over here on our .git folder. That basically took that blob, gave it some information, and is storing that in the index for now. Yeah.
What happens if you don't cache info?
Cache info, I'm not entirely certain. We can look at what it does here. Cache info. Okay, so cache info is the command that writes it to the index. And we give it a file node, the object ID, and then the path, which is going to be the file name.
But you already specified add, so is there something else you can do by adding other than cache info?
You can remove.
But we specified add and cache info, didn't we?
Well, you give it the cache info. So that's the information about what is. So you're giving it the data now when you're adding it.
Okay.
If you use remove, you'd have to give it the cached info that you gave it before to take it back out.
Okay.
Yes, that's a good question. So that's what that does. Yeah. And also, every single one of these commands has a man page because everything is well documented. So yes, wonderful. Some are more well documented than others. Like if you look at you use GitHub update index. You can see. Actually, this one has. This is actually this big man page. But compared to like Git log or something, you know, I have not actually read through the entirety of that, but that one has nice pretty pictures and everything. Hash object is like 2 sentences. So we wrote our blob to our index. Now comes that tree object. So we have a blob. We now have associated that blob with a file name. And if we actually look at git status, you can see git status isn't really happy with us. It says we have this new file that we've created and we're going to commit. But we're also deleting that same file because we've never actually put this file into our repository. So we've never actually made a file. But Git thinks there's a file because we told the index that we had stuff in there. So git status is like that. The next thing we need to do is actually is make this tree. So we need to take everything that's in our index right now and give it a little bit more information. So this is a really simple command. Write tree. So that write tree by default just takes everything out of your index and makes a tree object for it. So the reason why we need a tree object is that is going to give us the information about our directory structure. So we have this tree now, and we can actually use Git Cat File again, and really cross for the type first. I can actually type this in here. 7DE. And we can see that it's a tree type. Git, you really only need like the first 4 characters of a hash with Git, because chances of the first 38 characters of your hash being exactly the same as another object is pretty slim. But we can also print this out. And you can see here, we have the file mode for our blob, which is this, and a file name for it. So that's all that's really stored in a tree. You have blobs. You can also have trees in here that point to directories.
Write permissions are stored in Git.
Write permissions are stored in Git. Because you need to have that information about the file. It's just more metadata about the file. Because Git doesn't actually store the files, it stores the file's information. So like blobs, they don't have any write information about them, they just have the content of the file. And so trees will store the write permissions and the name, and then also represent a directory. So that's write tree. Next thing we're going to do, now that we have these trees and these files, is we're going to make a commit. And we're not going to use git commit. Of course not. Why would we do that? That would be too mainstream. Where's our mouse go? Over here. So I need to actually copy this. So this is our tree, and we're going to commit this tree. And commit and commit tree are very similar commands. Commit tree, you're just pointing at a specific tree that you want to commit. So this one actually could be more useful in real life. So, and there we go. So now, you can see our object directory looks oddly familiar to the first time that we did this. We have our 3 objects. And those 3 objects make sense now. This commit hash right here, that's all it is. It is a commit hash. And if we ask cat file, what's what the type of this is. It's 32BB0. It's a commit. And we can ask to have it printed out nice and pretty, and oh, look at this. This looks familiar, right? You know. Git log. No, okay, Git log is still not happy with this yet. Because there's still one more thing that happens when you commit. Where's our head pointing right now? We still don't have a branch or anything yet. So right now, head is pointing to a master branch that doesn't exist. So what we need to do, and to be a good citizen, we have to update our refs. So basically what we need to do, I should copy this here. So I'm going to need that. So we're going to make our master ref, and we're going to put our hash in there. Alright. Now, Git log is happy, and it knows where our top commit is. So every commit has, this is how Git log works. It looks at your ref, what branch you're on, looks at that commit, prints out that commit, looks at the parent of that commit, prints out that commit, and so on and so forth. That's a fairly simple command. And if this looks familiar, you can see this. I can actually do one more thing. You can see there's our tree that we wrote. So we made a commit with a tree, because that's what a commit needs. All a commit is literally this. If you use cat file and have it printed out, you get this exact same thing. You have, except minus your commit hash. You get the tree that it's pointing to, author information, time of commit, and commit message. And that's really it. Other than Git status not being happy with us, you know, saying we still deleted that file. All we need to do is now check out of our repository. This. And with most Git commands, if you do this 2 dashes, it tells Git to only do this command on a particular file. So I can actually tell it, I just want to check out this one file. And this actually works on a lot of Git commands. You can use reset for this to reset individual files. You can reset, if you don't put it there, it just does it on your entire repository. So that can be really helpful sometimes. So we're going to check out this file. If we ls, there's our file that we made without ever actually making it. We told Git that we had it. We told Git the information that was in it. We told Git some information about it. And Git thought it was there. And so we git checkout basically goes to your head, goes to this tree, creates all these files with this file information, reads the blobs and puts the data in it whenever you check out. It's probably a little bit more optimized than that, but checkout works pretty fast. If we can see, there's our file. It's all there. So that's making a Git repository and adding files without using add or commit. So why on earth would you ever do it this way? The answer is no. You would never actually do it this way. This is a terrible way of actually using Git. In the course of, I don't have a clock, in the course of 20 minutes, we made a single commit. About 30, okay, 30 minutes. So that would be a pain if it took 30 minutes to make a commit. The reason why I think this is important to know is because it gives you an idea of how Git is working on the inside. So come a situation when, I'm going to jump back into my slides. So yeah, why did we do this? So come a situation where your Git repository is broken and you don't know what's going on, and all you know is add and commit, you're not going to fix your repository. Unless you have an understanding of really how it works, it's going to stay broken, and you're going to do what I did when I was new to Git, where I deleted the Git repository and recloned. So don't do that.
I don't know about you, but I just rebased hard every time.
That's just going to break things more. You know? So, but the idea is of this porcelain versus plumbing. These two words come straight out of Git. What's the difference between porcelain and plumbing? It's the bathroom analogy. Porcelain is all your shiny sink stuff that you use every single day, and the plumbing is really what composes of it. So on an everyday basis, all you really need to know is the porcelain. But say something breaks in your bathroom, or you're a plumber, or if you're reworking something and you're fixing something, you're going to need to know the plumbing. So these plumbing commands are what makes up Git. And if you know some of these commands, you can be that guy on your team that can fix anything in your Git repository, assuming you're using Git. So any questions there on actually anything that I just did there? Yeah.
So a tree object is only ever going to contain the files in one directory, correct? And references
Yes.
to other trees.
Yes.
So if you were to say name a file in a subdirectory with like a slash, would it just like blow up and be like, no, I'm
It
done?
would make a file with an escape slash in it.
Okay.
Yes. It did say path in the man page, but it won't take a path. I said well documented, right? So trees are just in the current directory, and it points to trees that are subdirectories, and the trees, their file name would be the name of the folder or subdirectory. So, any other questions on that? Because now we're going to kind of get into some other Git things that not everyone's completely 100% comfortable with.
Sorry, I keep asking
Okay.
questions.
No, please do.
So does that mean when I run like git status and it's telling me all the untracked files, it does a full sweep of my entire directory to look for files that are
Yeah,
untracked?
so Git status looks at your current working directory and compares it with your staging area. So when you actually make a commit, your index is wiped clean.
Okay. One last one.
Keep going.
How does Git infer that if I like moved and changed a file, sometimes it'll pick that up? Does some fancy something?
There's some additional. This is really kind of basics of what Git is. There's also packing that I didn't cover in here. Because if you look at a normal Git repository, your objects directory isn't this massive thing. There's this pack directory that actually stores packed objects. But back to your question, there is a mode when you add that you can detect changed files. And so Git has a whole other set of algorithms in their software that does that. But at the base level of what a Git repository is just these objects and everything. So what's nice about having blobs that aren't associated with file names is when you detect that file change. So like when you're hashing the file, you're not hashing the information about the file. You're hashing the contents of the file. So Git's going to be able to tell that if these two files have different names with the exact same content, guess what? They get to point to the exact same blob. But it'll make two files if you have them multiple times in your tree. All right, any other questions? All right. Anyone here comfortable with rebasing? 2.5? All right. 3? Okay, so this is kind of a topic that, the question always is should I rebase or should I merge? I can tell you right now, this is not the question you should be asking. If you're asking this question, you do not understand what rebasing is. They do two completely different things. The real question is, what do you want your history to look like? So, what rebasing does is basically, there's two ways of doing it. If you jump onto another branch and you rebase, what it does is it takes all of your history on the branch you're rebasing from into, takes all that information and makes it happen as if I was here and I did all this stuff right now. So it takes those commits and rewrites them on top of your branch. So obviously all your commit hashes are going to change because your parents are changing and everything. But so, here's the kind of the separation of the two. This is an example of after you rebase, you have a nice straight line history. And here's what a merge looks like. What a merge does is it creates an extra commit that has two parents. And so it can actually have X number of parents. You can have as many parents as you want to a single commit. But basically, it's where this came from. So every commit has a parent except for your first one, it just points to nil. But, so rebasing doesn't have that extra commit. And for some things, people feel that if you have small bug fixes or something that you branched off for because you thought it was going to be more complicated or something, or people who do branch for bug fixes that might turn into something bigger, you can rebase those in, and it's not that big of a deal. You can actually rebase and push and not screw everyone over on your team. It is possible. Because rebasing is just going to write those commits on top. Now, if you do an interactive rebase and rewrite part of your history, or you choose to jump back in your history and then rebase a branch in and then somehow not just screw everything over, anytime that you're rewriting your history, it's usually a bad time, but rebasing branches together isn't rewriting your history, because that other history is still there. It's just rewriting it somewhere else. So actually, kind of show a demo of this. So I have this fun command called lots of commits. How many commits do you want to make right now?
723.
42.
That's under
42.
to make this
6.5.
4.
-1.
I heard 7. I
314.
7. That's a good number. Okay, so I just made 7 commits. I added 7 files with names, respectively 1 through 7, and I added them to my Git repository. So you look at Git log, you can see that what I was trying to do was add 7 files, but say I'm one of those guys on the team who likes to commit a lot, and I'll be honest, I'm not that guy. I should commit more. There's actually another command that I'll show you called git add patch mode, that if you don't commit enough, this can make your life better. So commits are supposed to be really precise at what you're trying to say. It helps when you cherry pick things or you revert. You want a commit to do a single thing. You don't want to be, oh, in this commit I, implemented this feature and I also fixed some syntax errors over there. So then all of a sudden you're having a conflicting message in your commit, and you're just going to have a bad time if you ever need to revert that. All of a sudden you reverted a syntax issue, and now that syntax issue is back even though you thought it was gone. So your commits should be very concise. But they also shouldn't be like this. This is ridiculous. Your team's going to hate you if every time you push 50,000 commits for each character that you wrote in a file. So that's a bit ridiculous. So what we can do is we use Git Rebase. It has this thing called interactive mode. So what this is going to do, interactive mode will take from where you currently are and number of commits back. And there's actually this cool syntax on head that you can do. Basically what this is saying is take my head and go 7 commits back from this. If you do head caret, this is your last commit you just did. If you just caret caret, it jumps an additional commit back from that. So this is really helpful if you say, oh, I need to go 5 commits back. You don't have to go look up the hash for it and then put the hash there. We're going to want to go from where we currently are to 7 commits behind from where we currently are. So when you do run Git Rebase Interactive, it drops you into this interface here. It gives you the option to pick commits or squash them. It's got everything right here what you can do. And so what we were really trying to do here is add 7 files, and we really kind of wanted to do that in one commit. So I'm actually going to go through and delete all of these first. So we're going to pick that commit, and we're going to squash the rest of these. All right. So what it's going to do, it's going to go through and replay the history based on this recipe that you gave it. So it's going to go through, all right, first commit, you wanted that one. You also wanted to squash these next ones. So we're going to run these ones before we do this commit. So it's going to take all of these commits and put them back down to 1. What it'll also do is it'll make your commit message everything, which is kind of annoying. Get rid of most of that. We'll just add we added 7 random files. That's really what we were trying to do. So if you look now, we have 1 commit, we added 7 random files. So this is the rebase that can be really dangerous. You want to do this before you push, because then the rest of your teammates are going to hate you, because this rewrites your history. I've seen a lot of people use rebase incorrectly. When people say, I'm going to rebase my repository to fix everything, there was nothing broken with your repository. Like you just had, like maybe some of your commits weren't very concise. But I don't feel the need that you need to go through and clean up your history all the time. That's just my personal preference. If it's that important that your history is, perfect and there's nothing wrong with it, then you can go through and rebase the entire thing. But all the history is still going to be there. And another great, wonderful thing too, say you did this and you screwed everything up, or say you ran a command and you screwed everything up. You didn't screw everything up. It's still all there. Reflog. So reflog keeps a history of everything that you did in Git. So there's a lot of stuff in here. You can see there's a lot of rebasing commands in here. But we also have, we go even farther down. We have, added all our random files in here. So I actually don't know where the information for this is stored. It's not in the .git folder, it's not obvious in the .git folder. But it stores a history and the hashes of where you were. Since all these objects are still here, every single one of these commits that I made, they're all still there. They're all still, and you can now see in the mess of our objects directory over here, all those commits are still there. They never went away. So what would be the point of version control if you did something and you blew away part of your history? It wouldn't be very useful, would it? So you can always jump back. And you can see rebase makes a lot of noise in reflog, but I suggest as you're using Git, if you just look at reflog as you do things, you'll notice there's a nice syntax for, you can ask for head at something, and you'll jump back to that commit. So if I wanted to go back to before this rebase, you'll notice that the rebase starts out with a checkout. So it checks out that current branch. So what is that, head at 7? So if I do git checkout, head at 7. Actually, what I want to do, excuse me, I don't want to check out. I want to reset. Not like that.
It's
Okay, there we go. Okay, so now, oops, I think I have to go one more back. I need to go back before I need to go back before the checkout, actually, because I need to go back to that last commit that I made. So I actually need to go back to 9. So I go back to 9. You can see that all of my history is still there. So even if you rebase, your history is still there. So don't think you can rebase things out of your repository. You can't.
But if you push and then you clone it somewhere else?
It's all still there.
Oh, really?
So what happens if I, say, accidentally commit a password or some sort of sensitive information?
So there is a way, and Git actually has this. You actually really like this because it's very similar to a MapReduce kind of thing, where you can go through and go through your entire repository and actually remove the information.
Mm-hmm.
I've never had to do that, but there are. It is specified in the Git documentation. There's a whole tutorial on how to do it. For if you really need to remove something from your repository, there's a way to go through your entire repository and remove it.
Mm-hmm.
So, as you were saying, if I clone this repository somewhere else, I still get every single one of these objects. So everything from the repository still gets cloned. So, that's about all I want to talk about. Just one more thing I want to mention before we go. I want to thank you guys all for coming. Slides are up on speaker deck. But I'd like to give a special thanks to Tim here, who works at GitHub. He gave a talk, Git from the Bits Up, closer towards the beginning of the summer. It was an absolutely wonderful talk, and it actually is what inspired me to give this talk and actually learn a lot about Git this summer. So I can't do this talk justice compared to what he did. Google it, look it up, it's absolutely great. So yeah, thanks for coming.